This is Doug Turner food processor problem. It requires you to use LP technique to identify the solution. So in this example, I'm going to be taking some time to go through all the phases you need to solve this type of problem. That including making sense of the problem description, identifying the parameters and objective functions, and the identifying the constraints, and then turning them into the mathematic format, and then moving on to Excel. So I'm just going to take some time to walk through all these different steps. Okay, so if you're in a phase where you just want to take a look at the Excel solution, feel free to fast forward. But if you are sort of needing some kind of detailed instruction on this type of problem, I think you better stay and watch from the beginning. So the first challenge, the immediate challenge you will be facing by looking at this type of problem is you need to make sense of the problem description itself. You need to understand what is the nature of the problem, and we need to start from there. And then there are some other informations that help you to formulate mathematic models. So, I mean, that all starts with a solid understanding about the nature of the problem that this particular company is facing. Okay, so let's take a look. This is a company that makes some kind of dog biscuit, a new brand of dog biscuit, composed of chicken and liver flavored biscuits. So essentially, from my reading, that they are currently making a package, right? Some kind of assortment with half or maybe some proportion is chicken flavor, right? Here's chicken flavor. The other half maybe not half, but the other parts will be liver flavored. So I don't have any pet, so I'm not really sure what kind of animal like liver flavored. Okay, so you have two type of flavor. Yeah. So this part will be so-called chicken flavor, and this part will be your liver flavor. So two together forms a dog biscuit package. So um, they both looks like they both have the same nutrient composition, nutrient A and nutrient B, right? So is the liver flavor also has nutrient A, nutrient B, but in a different quantity. In a different quantity here. I think I skipped. Okay, and it also looked like there's some government federal requirements that we need to consider. I assume that that becomes our constraint. But anyway, so you have chicken. This is the way I would organize information. You have a liver flavor, chicken flavor, and you have nutrient A, you have a nutrient B. So they'll give you a nice matrix like this. Okay, this is easier to organize information. So you need 1 unit, you see, you need 1 unit of nutrient A, 2 unit of nutrient B for your liver flavored biscuit part. So 1 unit A, 2 unit B. Yeah, I'm being very cautious because I don't want to make a mistake as I work on this. And number two is a chicken flavored biscuit contains 1 unit of nutrient A and 4 unit, right? 4 unit of nutrient B. Yeah, so this is their composition of nutrient. Okay, and what else information do we need to know? So it looks like the federal requirement asks that there must be at least 40 units. At least 40 units, right? The meaning that once the quantity is determined, um, the the quantity for the nutrient A must be at least 40. Okay, so at this point, maybe it's easier to think about what's our decision variable is going to be. So most likely it's some kind of maximization and minimization based on the quantity of each biscuit. Okay, so I'm just gonna say my decision variable is quantity of chicken in each package, also the quantity of liver flavored biscuit in this package. I'm going to use x1 to represent the quantity of chicken biscuits that goes into the package. I'm going to use x2 to represent the number of liver biscuit that goes into the quantity into the package. So I'm using x1, x2 because I don't really know what is the eventual quantity as look like when we solve the problem. Okay, so let's think about the first constraint. So this is going to be our subject 2 part. So it says it must be at least 40 unit of nutrient A and 60 unit of nutrient B in the package level. So it means, so for nutrient A, these two are determinants of your nutrient A quantity, right? So you have 1 unit of nutrient A in all the chicken biscuits plus 1 unit of unit A nutrient, I'm sorry, 1 unit of nutrient A each biscuit with all the number of biscuits. So 1 unit each biscuit multiply by the number of biscuits. 1 unit of nutrient A per biscuit multiply by the number of biscuits. So they together forms the total number of, right? They together becomes the total quantity of nutrient A. Okay, but this is what? This must be at least 40. So the sum here should be greater than or equal to 40. It must be at least 40 units, right? So the same thing applies to nutrient B, right? So the same thing applies to nutrient B. So it's going to be 4x1 plus 2x2 need to be at least 6 units. So I'm going to do this. Okay, and this is the 2 constraints that we need to consider as we search the answer. And what else do we need to know here? The company has decided that there can be no more than 18 liver flavored biscuit in a package. So they don't want to include more than 18 liver flavored biscuit in a package. So we can convert it. So I think x2 is our liver flavored, right? So x2 should be less than or equal to 18 in terms of its quantity, because it says they don't want to include more than 18 liver flavored biscuit in the package. Okay, and I believe we have all the constraints from the description itself. If you go through the problem yourself, if you're able to identify more, you can see if I got everything here, but I believe I have everything here. Okay, and then what is our objective function? Our objective function is going to be, they want to, come up with this biscuit package that minimizes the firm's cost. To me, it doesn't exactly make a business sense, but since this is a problem itself, I don't want to rant too much about it. So your objective function here is going to be, let's see how much each cost. Okay, so you can use more space here. Cost for chicken is 1. Cost for liver flavored is 2. Am I right? Liver flavor is 2 cents and chicken flavor is 1 cent. Yeah. So your total cost will be 1 cent multiply number of chicken flavored plus 2 multiply by the number of liver flavored biscuit. Okay, so we will eventually figure out the quantity for this x1 and x2 using the solver. Okay, but I think before we move on to Excel, let me just highlight a couple of areas that you need to know in this step of the analysis. Okay, so we know all the parameters. We know all the parameters here. Okay, this is all the given parameters that we know. And we now know our decision variables is x1 and x2. So the reason why we're calling this as decision variable is your total cost is eventually going to depend on those variables. Now we have a objective function. This is our objective function. We seek to minimize this. Okay? How do I know this is minimization? Based on the description of the problem itself. So first key thing is to obtain decision variables. Second key thing is to obtain your objective functions, and you also need to know whether you are maximizing or minimizing something. And third important thing is to identify all these constraints. So in this case, we have 1, 2, 3 important constraints. Okay, so I'm going to pause here for a second. I'm going to move on to, I'm going to start a new video that shows the Excel steps based on what we have done so far.